Chris, welcome. This is ML's Like Teen Spirit. My goal of this interview is to bring machine learning practitioners to regular business folk so they can have an explanation as to how it really is. Chris, you've had a long career in data science. You even have a PhD, so Dr. Chris Pearce is with us. But Chris, tell me, is this the proudest moment of your career?
Absolutely, JC. It's always a pleasure talking to you, but under this banner, yeah, absolutely the pinnacle. It will be difficult to relive this.
Good. Thank you for your support. So, Chris, I've been working with potential customers, people I know, people I meet for, definitely the last 2 years, talking about data sciences the whole time. And a question that I'm often asked is, well, what is the difference between AI and ML? And I'm sure I give quite a fluffy answer, really. One I sometimes go with is, are you talking to management or are you talking to investors? Is a little joke I make. But yeah, really, I'm trying to cover my lack of knowledge as to what the answer is. So I'd love for you to chip in and try and answer that question, please.
Yeah, I'm also asked that question quite a lot, and my answer is usually quite fluffy as well. I think machine learning has always been a subset of artificial intelligence, but a very specific aspect of that. Obviously, with the advent of generative AI, that question has become a little bit more prevalent now. I think the way I always try to answer it is machine learning is a series of algorithms and techniques that are essentially trained on a certain understanding of the world or data, and they reproduce information that has already been seen by them historically in order to forecast the future. AI, however, is able to take information that an ML model has seen and produce something entirely new from it. And that usually, in the practical world, comes out or seems like it's some sort of reasoning behind the capability. And I think that's the subtle difference between the two. It's repeating things that have already been seen before versus producing something that hasn't necessarily been seen before. And to the layman, that is perceived as something more in terms of a machine that's able to provide context or reason to a task.
So on a real example, everyone is using generative AI, or at least in my echo chamber, it seems that way. So an example is, being able to write some text that's, never been seen before. It's very specific to the question being asked. AI is an answer, unlike any other text in the training set.
Absolutely, and there's lots of examples banded out there about ChatGPT is able to write poems off a series of prompts that are new. Now they're derived from poetry that's been written by people in the past, but what comes out of that algorithm is something entirely novel.
Yeah, I tried to have it write a poem for my wife on her birthday, but she just didn't like it.
Just need a few more prompts.
Yeah. Chris, you're a head of data science. What I would like you to do for the rest of this segment is really, let's go back a little bit. I am going to show my age, is that it was statistics when I started. We have a grunge music themed show, so people can pinpoint my age, I think. It was statistics when I started, and I feel like every few years it's taken a little inflection, got more and more exciting as my career has gone on. I'd like you to first spend 60 seconds explaining why you're qualified to talk about all this. So could you give us a rundown of what you've been doing over your career, and then segment straight into, it was statistics and kind of what happened next. So the history of data sciences, because it didn't really exist a few years ago, or at least the expression. So I'd love to get your view on what were those different steps, what was kind of happening that was different at the time, and even from business standpoint, like how were businesses changing that meant they had to take new methodologies, new approaches, and take these relabeled formats.
Yeah, sure. I'm of the same age as you, more or less. So I've been through it all too. A little bit about me. So I studied a PhD in computational statistics. So stats was my calling in the early years. Since then, I've had 15 years working in applied data science. I've worked in a number of different industries. So FMCG, retail, automotive. various financial services, so corporate banking, marketing functions. That's both client and agency side. And most recently, I've spent the past 10 years in insurance companies, but luckily enough, I've been sort of involved in centralized functions within those companies. So, touching everything from pricing to reserving to claims to fraud to telematics to marketing to premium finance. So, a vast array of applied data science, if you like. And certainly over the past 8 or so years, I've been involved in building out and scaling data science teams and capability from scratch in business.
Chris, so you're our guy. You've been there, you've done it. Well, so it was statistics when I started, and I was doing something called linear regression in a forecasting team is where I started. So we were doing statistics, and I'll tee this up for you. I remember feeling like analytics was being invented and starting to pop up in like different departments of the company and these things. And I began to be sort of seduced by it and moved into different directions and ended up in marketing. But I'd like you to explain, your opinion really of like how do we move out of statistics into what is analytics, and then carry on, because there's multiple big pops
Yeah,
in
for sure.
the timeline. So like, take it away, Chris. I'd love to know what you think was the difference at each step.
And it's cyclic in many respects. And my very first job, technically, my job title was a statistician. And I think, sort of the boom of the early 90s, arguably the early noughties as well, is, the internet had arrived. Commercial statistical software was starting to come to the foreground. So, you had things like SPSS and SAS were pretty ubiquitous across industry. And that gave business the ability to crunch data and be able to collect information about customers that we probably never had sight of before, and make inferences and predictions about the future, which obviously, if done in the right way, can create commercial value. So I think statistics was the boom, but despite that, we were still in a world where not huge volumes of data were being collected. And so, paradigms like hypothesis testing and how you sample in order to, make inferences with the right amount of confidence, the statistics was still very much needed because it was expensive to store and capture, vast amounts of information and be able to stitch it together in the right way that, you could start basing a model off. So, I think at that point, statistics was still very much needed. You skip ahead to the sort of mid noughties, Yahoo had open sourced Hadoop, and suddenly storage in particular was becoming considerably cheaper. And we started to see the emergence of technology like Hadoop, and then companies like Cloudera and Hortonworks that would package up all of that open source ecosystem and try and sell it as a service to business. I think that really started the phrasing of big data, right? So this was sort of a step change in, well, now actually we're able to capture data on a much bigger scale. We're able to do it a lot more cost effectively. And because we've got much more of it, more classical statistical paradigms like how do I over undersample weren't necessarily a concern anymore. We had data. The problem then became, how can we leverage this all in an efficient way? And then, of course, obviously that gave rise to concepts like MapReduce and parallelization of compute, so that we could run big jobs at scale concurrently. And that's really
let me pause you. No one knows what that means. We are bringing simple data science to our audience. So you mentioned something called MapReduce. Would you be able to explain why it exists and what is really happening there?
I want to do 10 things at once that are all really computationally demanding. So how do I do that? I can't do that on my personal computer at home. What I actually need to do is I need 10 computers, and I need the ability to tell computer 1, do task 1, computer 2, do task 2, and so on. So the term MapReduce is effectively a paradigm that enables you to be able to do that, run more at the same time, cost effectively, where you're not having sort of a chain of dependency to wait to get your output. And that was a huge step forward technologically and in terms of what you could do with data. And that's where I think the term data science started to become popularized, when analytics then really became at the forefront and the foremind of executives. Suddenly you had this ability to really canvas vast amounts of information and data and query it and answer really deep questions and bring about insights that would actually help business strategy, business process, benefit customers and tailor your product to their needs. And all of this at a scale that was dreamed about years before. And that changed the course of history. The data science market boomed. I think it took a long time before people really understood what a data scientist was, and the definition of what they do and what they need in order to do their job took a while to sort of crystallize. I think then, off the back of open source tooling, i.e. algorithms that are available to anyone technically, that world then really took off. Lots of researchers around the world were taking off-the-shelf algorithms, modifying them for their own purposes, and then posting them back up on the internet, right, for anybody else to go and use or build upon. So, we now refer to that community and that way of working as open source. That was really the start of when machine learning, in my mind, became available to individuals, but also to businesses. And not only did it become available, it became available in essence for free on the surface of things. Employee could go away and download something off Kaggle or Stack Overflow and use it in the real world, and they'd have lots of data to use it on. Now, of course, the other side of that coin is actually putting it into production is a completely different matter, but we won't go there yet. So this was sort of
Chris, well, let's pause on that, because I promised my audience 12 to 15 minutes, and we're going to hit time. Let's try and we'll go into deep learning another day. Let's try and recap then. I felt like I heard you say statistics was always important, but the size of the data kind of defined it. Data started to get bigger, and the insight part became more important, is what I think I heard. I heard the big data, so as web particularly, generated data at a faster rate than ever before. There were new tools were needed to kind of process that data in a timely way. And then you jump to data sciences. So I think what probably happened there is, business world felt it had solved how do you even work with large data, but hadn't necessarily figured out what do you even do once you have it in one place and can process it. So data science became exciting. And then it sounded like you said machine learning means a wider class of algorithms becoming available. But the key part was really like coming from the open source community. So someone like me and you could, not have to license technical software. We could download a variety of different models to our machines and crack on with our jobs. And that kind of characterizes the machine learning expansion. Did that sound okay? Was I really listening to you?
Far more succinct than me. Yeah, it's perfect.
Okay, Chris. Well, look, we've hit time. Look, thanks for explaining that to everybody. We'd love to have you back. You're clearly a fountain of knowledge. Thank you for launching us. Everybody, we'll see you again soon.
Cheers all.